My name is Julian, and I'm iOS engineer at XCode. And today we're going to talk about how to create a React Native component. So before we dive into the code, I'd like to define what our task is today. So given an empty React Native app that you can create in your computer by running these two commands, right? This is running on the XCode simulator, right? And we would like our JavaScript code to talk to some native code in Objective-C, but it could as well be Java for Android. And then we also want to be able to repeat this process, right? So let's look at some JavaScript now. On our typical app, we will add a call to our React Native My Library, which is where we'll put in our bridge code. And there will be two functions here. So function 1, which is just greeting, will print to the console from the simulator, which could as well be running logic. And the other one, which is greeting with callback, will trigger, of course, a callback that'll return a response string with some process that the native code did. So note that we are calling setState on the callback return, which will trigger a React Native component to re-render after. So the placeholder string that is up there will actually not display if we get a successful callback from our native code. So on the Objective-C side, what we will have is the implementation file from our library, which kind of looks like this. There's two methods for the ones that we were showing up before. So for those of you who don't know Objective-C, the greeting there pointed by the arrow is the name of the parameter, and the second greeting is actually the name of the local variable within the function, right? And so what we're simply doing with that is putting what we get into a console log that we'll see through the simulator. Now on the other function, we add an extra parameter, which is this RCT response center block, which is what will trigger the callback back to JavaScript land. And whatever calculation we want to do in there, or simply just native code that we want to paste into our function, this is sort of the way that we would do that. Might as well be reporting suit that there's no compatibility layer for React Native and so on. But we want to be able to repeat this process, right? So knowing that that's our end goal, we would like to come up with a way of first bridging to our native library and then being able to do that as many times as we need. So I was like, all right, well, let's do this. But where do we start? We start where most of an undefined new tasks start, right? Which is Google. Let's just open up Google, type in our question, and search. Maybe I'm feeling lucky. If you're feeling lucky, hit the search, and the first search result, or say, oh yeah, sure. If you want to do this native library, you just type in these two commands in your terminal, and you'll get to go. That's it. That's not quite right? Yeah, well, that's not what happened. And did you think that would be what happened when you estimated the task? Because I kind of thought. Anyways, I spent 2 hours Googling, no result, not even in the official React Native documentation. I was like, all right, dead end, what next? Well, maybe ask the community. So went into the React Native documentation website and opened up an issue there, asking if anyone knew of a way of bootstrapping a core library that was repeatable. It was at a command in the React Native command line tool that I didn't know about. And I quickly got a response from one of the main guys at Facebook maintaining this repository saying that they didn't know about it. So I was kind of mind blown at that point. So where do we go after that? Well, someone must have done a component before, right? We probably use, if we're doing a production app, a third-party component. So I try to look for the most popular ones, and the camera is one of the ones that are third-party, not included in the core library. And I navigated their GitHub repo, understanding their project structure. So there's an iOS folder where the iOS native code lives. There's an Android folder where the Android native code lives. And so far that's all great. But what do I do with that? Should I fork the repository and rename all the files and bash it until it looks like what I want it to look like? well, maybe I could do that, but once I'm done, if I ever get my code to run, will I be able to do it again? Probably not. So yeah, that doesn't scale well. And finally, after some searching, I came up with this library on the internet, which is an npm package, third party, not done by React community. So you can just install that using npm, and once you do that, you'll have a command available, which is React Native create library, and that will give you some of the files that will then be able to use to bridge. Before we move on, a good tip here is always use a local GitHub repo. So you can do that easily with these commands here without opening a new GitHub repository or anything. You can just add all your files there and then do local commits so you can see how your local files are affected as you do operations on them. But so what that command triggers in the file system is a project structure that looks like this. And this is starting to look to the previous React Native camera that we were navigating before. So you can see there's an Android folder with some Java files. There's an iOS folder with some Objective-C native files. There's index.js where you could put in a JavaScript wrapper of your native code if you want it. And there's a Windows folder too. So anyways, these are seen as assets for NPM's point of view. I think this is an important concept because when I was looking at how to create this, I was like, do I need to tell Node that I'm doing a React Native component versus a Node.js component? And the answer for me was no. All the native code here is just seen as assets from NPM's point of view. So whatever you put it here might as well be an image. It'll just be uploaded from that standpoint. But then we'll do the linking afterwards. So before that, once we have this local library in our computer, we need to tell my app or the local app to use that library so we can start talking to it and developing. So one way of doing that, which is for me the hard way, is on your package.json for your app. You can list your library as a dependency at its latest version because it's in development. And there's a long tutorial there on how to install your local npm package to your local global npm directory so that you can run npm install and have that into your app. So don't worry if this is confusing. Let's just move on to the easy way. So all the files that we had there before, we just grab and copy into our my app node modules folder, which we had from the first slides command. And then we'll link it to the app. So now we're using the React Native command line tool, and we're linking the library. So what this will do is both for iOS and Android, it'll alter the basic app project structure to include your library now. And then you can run your code. So the code that we had in the first slides, we run in the simulator. And then we get both the log for the first function that we defined, and then howdy world was the output of the React Native with callback function. So far so good. But why was this not part of the React Native docs? Because no one really should go through this pain again ever. So well, we can make it be. We can just go back to the React Native website repository and open up an issue. The repository is actually all Markdown, so it's pretty easy to edit. So I went and did that. Even in the browser, I didn't even clone the repository on my computer. And I typed that instructions that we were just going through. And whenever this is approved, that'll be part of the docs. So that's kind of cool that you can also give back to the community. So the conclusions for this is, well, open-ended task. Usually if you're at work and you get an open-ended task like this, make sure to follow a logical path to tie those pieces together. So in this case, well, we know we had an empty React app. We want to talk from JavaScript to native code and so on. Local Git repositories are really useful, especially with this tools to do destructive operations. So like when you do a React Native link that affects your local app, all those steps that you might affect your project, it's good to know what those are by just running a git diff. And account for uncertainty. for this kind of things, try not to think that the first Google result will bring you the answer, because that's usually not the case. Yeah, that's mostly it.
When you're defining the module in that first file, I noticed you're defining the source code in there too. What is that? I'm not that familiar with JavaScript. I'm a native iOS developer.
Okay.
So what are the golden RCT export? What are those technically?
These are preprocessor macros.
Objective-C? Oh yeah.
Yeah. So for anyone that doesn't deal with C or Objective-C files, these are preprocessor macros, which basically tell the compiler to paste in some code in place of this, and that code is defined by the React Native library. And so the first one, what it does is tell when you do that import for native modules out there, it'll know that you now have a library called ReactNYC, which you can use in that const variable out there. The other ones is basically wrapping your function definition in Objective-C and again exporting them so they're available in JavaScript. So greeting will be the name of the first function, and then the other one will be greeting with callback for them to be accessible in JavaScript.